All right, welcome back, everybody. This is a video going over section 6.3, synthetic division. Shout out to all Mrs. Apple's kids watching this too, because this is the only video we're making from this. So if you're watching me for the first time, welcome. Welcome to Mr. Laverick's classroom. Hi, Mr. Laverick. How are you doing? All right, so for those of you, again, if you've watched the long division video, you've seen that dividing using polynomials is kind of difficult, especially with long division. Hello, sir. Did you still need the guided notes for synthetic division, or did you get
I can get those. I do need those.
You do need those. Okay.
Should I put this on there like that?
No, you keep that. You're good. I'm teaching it in here so I can make a video. So. All right, so synthetic division. Again, I was talking about long division. Long division is kind of a labor-intensive process because, you know, it just takes a while, right? So synthetic division, you guys are going to find, is a lot easier. Synthetic division is a heck of a lot easier. So you may be thinking, well, why did we learn long division? Why aren't we only using synthetic division? Well, synthetic division you can only do when you're dividing by a two-termed polynomial. Okay, synthetic division is a shorthand method of dividing a polynomial by a linear binomial. Basically two terms. Okay, that's the sticking point for synthetic division. You can only divide by two terms. If it's anything other than two terms, you've got to use long division. Now, nice for us, we are going to mainly be using dividing by a linear binomial for the rest of the year, which is really good. So we can use synthetic division a lot, which is great. Another thing you have to watch out for with synthetic division, you have to write it in standard form. It's got to be written in standard form, greatest to least in terms of the power. And also, all terms must be represented, okay? Using a zero and any as a coefficient for any missing terms, okay? If anything is missing, you have to write it in as a zero. Like, say you had if you had like an x to the third plus x to the third plus 2x minus 4. Do you notice how the x squared is missing? You would have to write as a placeholder, you would have to say x to the third plus 0x squared plus 2x minus 4. Every term must be represented, okay? And you'll see why here in a second. All right. So here's the method. Now, this looks really confusing. It looks just like a weird arrangement of numbers in the end. But I got to tell you, the process is pretty slick. So here's what we do. This is the example that we're working with, okay? I'm dividing 2x squared plus 7x plus 9. I'm dividing it by x plus 2. Okay, so what we have is we have this number inside the box, and then we have a horizontal line coming across, okay? The number inside the box is generated by this piece here. It's whatever you're dividing by, right? So I'm dividing by x plus 2. How does that become a negative 2? Well, we just kind of set it equal to 0, and we say, okay, x is negative 2. That's the number that goes inside the box, okay? So negative 2 is in the box, and how do we get the 2, 7, and 9? Well, quite simply, 2, 7, 9. You just rip off the coefficients, line them up right next to the box, put a line underneath it. Okay? Now, what's the problem? So that's the setup, right? The negative 2 is in the box, the 2, 7, 9 coming across, and we have this horizontal line. So where does this 2 come from below the line? Well, we just drop that first term down. Every single time, you just drop the first term straight down. And then here we start synthetic division. You take the number in the box times the number below the line, and you put it up and to the right. So negative 2 times 2 is a negative 4, and we put it underneath the 7, the next number. And then we add vertically. You would take 7 plus a negative 4 to get positive 3. And then you repeat that process. The number in the box times the number below the line. Now it's a 3 over here, and that's where you get that negative 6. And then you add vertically. 9 plus a negative 6 gets us a 3. And that's where we end. And now, I'm not sure if Mrs. Naples does this, but the book always puts this little box around the last value. I don't normally do that, but that is just telling you that that is the remainder. Okay, the remainder. Now think about it. If I had taken something like, I don't know, 17 and I divided it by 4, right? That would mean I would have, oh, let's not do 17. Let's do 19. Let's do 19. If I had 19 divided by 4, we would see here that if there's 4 in there, so we have a 16. I know I'm doing long division, just deal. But what I'm looking at here is if I take 19 divided by 4, I've got 4 with the 3 left over, with the 3 remainder. So how would I create a mixed number out of that? I would say 4 and 3, the remainder, divided by whatever I was dividing by. 4 and 3/4, right? So what you're going to do here for to set everything up is I'm going to take the 2, put it as the coefficient on the x, the 3 is the constant, and now this 3 that's the remainder, just like our 3 that was the remainder with the numbers, we put it over what we were dividing by. 3 divided by, we originally started with it divided by x plus 2 up here, right? So I'm dividing by x plus 2. Now why did we know to start with an x? Well, we started with an x squared to what we were dividing, right? So all you do is just kick it down 1. You kick the power down 1, and that's what you start with. So instead of an x squared, we start with an x with our coefficients, so that's why we had a 2x. And then the 3 was the constant, and then the other 3 was the remainder. All right, let's try it. So this is, just verify with me, this is your example A for the guided notes, right? Okay, perfect. I know I had it screwed up in my groups yesterday. Okay, so I hope you would, those of you who have watched the long division video, I hope you would say that, like, wow, this would be kind of a difficult problem, okay? In synthetic division, man, it's pretty slick. Okay, so somebody tell me, what goes in the box? What goes in the box? Not 2, but -2, right? I take x plus 2, I set it equal to 0, I subtract over, I get x is equal to -2. So -2 is in the box. And now I've got to line up the rest of my coefficients. Now, the only issue is, look here, 3x to the 4th minus x to the 3rd. Is there an x squared? No. So we have to leave a placeholder as a 0x squared plus 5x minus 1. And now we line it up. 3, -1, 0, 5, -1. We draw our horizontal line here. Again, if you're in Mrs. Nepos' class, she might set it up just a little bit differently, but the process is still the same. So that's the setup. Any questions there so far? Okay. So here we go. Let's start. Drop this first term down. We get a 3. Right? Don't do anything to that first term. Just drop it straight down. And now we say the number in the box times the number below the line. -2 times 3 gets us a -6. We add vertically. -1 plus -6 is -7. Number in the box times the number below the line. -2 times -7 gets us a +14. We add vertically. Number in the box times the number below the line. -2 times 14 is -28. Add vertically. Number in the box, -2 times the number below the line, -23. +46. Add vertically. And now we're done. That's the process of synthetic division. Now again, how does that relate to what our answer is? Well, we started with a 3x to the 4th up here, right? We started with a 3x to the 4th. So kick the power down 1. Instead of x to the 4th, it's going to be an x to the 3rd. So these are our coefficients. 3x to the 3rd -7, and then start descending. X squared plus 14x minus 23. And then that 45, that last number left over, is our remainder. The remainder of +45 over, and we were still dividing by x plus 2. And that's my answer. Again, those of you who've done all the long division stuff, you can appreciate, wow, that was a lot less work than long division. A heck of a lot less work than long division. I would do this every single time, but the only problem is I can only ever do it when it's a linear binomial over here, unfortunately. Shall we try it again? Let's do it again. take a look at our next example here. X squared minus 3x minus 18, and I'm going to divide it by x minus 6. Okay, so what number goes in the box? Somebody tell me. Positive 6, good. Positive 6. And now every term is accounted for in what I'm dividing. So I've got a 1, a negative 3, and a negative 18. What do I mean by that? That means I've started with an x squared. That's the biggest power. It's in standard form, obviously. I started with an x squared, and then I have my x, and then I have my constant. Everything's there already. All right, I put my horizontal line going across. Drop down the first term. 1 goes straight down. Number in the box times the number below the line. 6 times 1 is 6. Add vertically, positive 3. 6 times 3 is 18. And hey, look at this. We get a remainder of 0, which means it divided evenly, right? It divided evenly. When you get a remainder of 0, you divide it evenly. I think 20 divided by 4. There is no remainder. It's just 5, right? Because 4 and 5 are factors of 20. Take a look here. It was an x squared. It just turns into a 1x and then a plus 3. And then you don't write the remainder because it's a 0. But look here. Isn't x plus 3 a factor of x squared minus 3x minus 18? If I factored negative 18, factors of negative 18 that add to get to negative 3, negative 6, positive 3. Look at this. Negative 6, positive 3, right? When you divide something by one of its factors, you get an even, you get a no remainder, right? You get basically like a whole polynomial. Okay, let's try one more. X to the third minus 3x plus 5. Go ahead and write out the setup real quick. See if you could just write out the setup. Okay, what goes in the box? What goes in the box? What goes in the box? Negative 2. Again, I don't know why I was so negative 2 back then. Now, watch here. 1, 0, negative 3, 5. Did you catch the 0? That's kind of a tricky part about this. There is no x squared term. So this really should be x to the third plus 0x squared minus 3x plus 5. That's where the 0 comes in. 1, 0, negative 3, 5. Okay, drop down our first term. Number in the box times the number below the line. Add down. Number in the box times the number below the line. Add down. Number in the box times the number below the line. Add down. We started with an x to the third, so knocks down to x squared. So 1x squared minus 2x plus 1 plus 3 over x plus 2. And that's my answer. Again, pretty slick, right? And you guys are going to get so good with this process that it's just going to, you're going to be able to do these very, very quickly. Now, the last little bit of this is just kind of like a cool trick. Like, I think it's like a parlor trick. If you're sitting around with your friends on a fun Friday night and you're like, hey, I can evaluate a polynomial really quickly. And they're like, how can you do that? And they're like, well, you can use synthetic division. Because I know that's what you guys do when you hang out on Friday night. You talk about math. But one application of synthetic division is called the remainder theorem. It basically said, remember this number that we had down here that we were talking about? We were talking about as the remainder. That remainder is actually what you get if you substitute that number in. Crazy, I know. But think about this. If I were to divide this polynomial by x minus 3, meaning a 3 would go in the box, that remainder down there is actually what you would get. That 7 is actually what you would get if you went into your calculators and said 3 to the third minus 4 times 3 squared plus 5 times 3 plus 1. If you actually evaluated it, right? Now, I know you guys would be like, this is stupid. I can just plug it into my calculator. Why am I doing this? Well, A, because it's kind of cool. And B, what if you don't have your calculator? This is actually a pretty easy process rather than saying, okay, I've got to figure out what 3 to the third is. And then I've got to subtract 4 times that 3 squared. And then I've got to take 5 times 3 plus 1. That you might mess up on that. But this process of synthetic division is just like multiplying and adding. That's it. Bring down the 1. 3 times 1 is 3. Negative 1. Negative 3. 2. 6. 1. 7. That's pretty quick and easy. Like I didn't do any complicated operations with that. So let's do one of these. Again, this process is called synthetic substitution. All right, x equals 2. So 2 goes in the box. I've already got what the value is going in the box. You don't have to make that like a negative 2 or anything. When I tell you what x equals, that's what goes in the box. When we line everything up, 2, 5, negative 1, and 7. Everything's accounted for. Okay, right away, drop down. 2. 2 times 2 is 4. Plus 5 is 9. Times 2 is 18. Add down is 17. Times 2 is 34. Add down 41. And that's my answer. See, the process is the same, but the solution, you just like interpret the results a little differently. So we're really just saying that now P of 2 is 41, right? If I plugged in 2 into, like if I took my calculator and said 2 times 2 to the third plus 5 times 2 squared minus 2 plus 7, I get 41. Okay. All right, let's do it one more time. This last one here. Again, think about the difficulty. If you do not have your calculator, wouldn't it stink to have to take negative 1/3 to the 4th power and then multiply it by 6 and then take negative 25 times negative 1/3 to the 3rd power minus 3 times negative 1/3 plus, heck no, I'm not doing that. But this is actually not so bad. If I take negative 1/3 in my box, I've got 6, negative 25, don't forget the 0 for the x squared, negative 3, positive 5, to the 4th, to the 3rd, squared, x constant. Everything's accounted for. And I run synthetic substitution, synthetic division. Drop it down. Remember that multiplying by 1/3 is the same thing as dividing by 3. So 6 divided by 3 is 2, and we got to make it negative. 27 divided by 3 is 9. Negatives cancel. 9 divided by 3 is 3. Got to make it negative. Negative 6 divided by negative 3, positive 2. That's a 2. 7. 7. That's what I would get. Wow. That is a heck of a lot easier than trying to take that power. P of negative 1/3 is 7. Cool, right? So if you're hanging out with your friends on a Friday night, be like, hey, I'm going to race you. I'm going to say, get out your calculator. Let's plug in some values, and I'll see if I can do it quicker on synthetic division. I mean, like, that's what I did in high school when we were sitting around, me and my friends. Just kidding. I know I'm a nerd, but I'm not that big of a nerd. All right, so long, everybody.